In our quest for sustainable architecture, the key isn't just reduction, but prevention, or as we like to say at Preoptima, carbon avoidance. And this all starts at the conceptual stage, where your ability to avoid embodied carbon is at its peak. An early stage approach is far more effective than compensating later with small reductions made during technical design or material procurement, or even through energetic retrofitting, which can sometimes lead to a net increase in embodied carbon if the materials used have long carbon payback periods. Integrating whole life carbon assessments and optioneering into conceptual design is in fact the best way to avoid significant emissions. At this stage, design options are still fluid, and you can assess all of the available design alternatives from the outset. Informed decisions made during conceptual design can prevent carbon lock-ins, which are choices that inhibit the future sustainability of the project and can also be costly and laborious to reverse. For example, choosing a high carbon material or building system during the early design stages without assessing any alternative design options can lock you into a carbon-intensive path for the entire project lifecycle and result in a high whole life carbon impact for your as-built building. This is where Preoptima comes in. Preoptima CONCEPT empowers designers to foresee and avoid these carbon lock-ins and starts you off with a low carbon baseline. Okay, let's dive into the platform. Okay, so I am in the Preoptima CONCEPT platform. I have imported my early stage massing model and I was requested to look at just two building parameters, which is the structure and the facade. So I went ahead and quickly optioneered for a few different structural systems and facade types and created 5 different design iterations, including my baseline design 1. So what I'm going to do is I'm going to come into compare designs, and this just provides a snapshot overview of all of my design alternatives. So as I said, design 1 is my baseline as imported. It is a reinforced concrete structural system with a traditional brickwork facade, and that came in at 678 kilograms of CO2 equivalent per meter squared. I then went and played around with a few different options. So I looked at a steel structural system with a curtain wall that increased my embodied carbon. I looked at a hybrid system, which is a steel frame with CLT flooring and a curtain wall that decreased my embodied carbon by quite a bit. Stuck with hybrid, looked at a precast concrete wall, decreased my embodied carbon further, and finally I looked at a hempcrete wall, and that gave me my lowest embodied carbon footprint for these different design iterations. And that's about, from our baseline, 111 kilograms of CO2 equivalent per meter squared reduction. If we multiply that by our entire building floor area, it'll give us about 5,000 tons of CO2 avoided, or 5 megatons of carbon avoided, which is pretty impressive given it took me 5 minutes to perform these whole life carbon assessments and the entire optioneering process. And if I wanted to use this as a deliverable for our decision making, I can go ahead and download a PDF or an OBJ of the massing model or an Excel file containing all of the material quantities in my massing model and the carbon impacts associated with them according to the scope that we specified. So that's how quick and easy it is to optioneer within Preoptima CONCEPT. By evaluating these options side by side, Preoptima pinpoints the design that has the lowest carbon footprint while still meeting all of the functional requirements of your project. This means that you can start your project with a low carbon baseline, and you've set a strong foundation for achieving a low carbon or net zero building. And this is why comparative insights early on are so important. In essence, choosing a carbon conscious design from the outset is not just good practice, but a strategic move towards achieving a sustainable, low carbon building.